Okay, so we're going to start 8.3. Show that a quadrilateral is a parallelogram. Converse of a definition of a parallelogram. If both pairs of opposite blanks of a quadrilateral are blank, both pairs of opposite what? Sides, good. Of a quadrilateral are parallel. I should probably make this a little bit bigger. Does that help a little bit? Then the quadrilateral is a parallelogram. So on Tuesday we said that if a quadrilateral is a parallelogram, then opposite sides are parallel. This is just the converse. So if I know that I have a four-sided figure, opposite sides are parallel, that makes it a parallelogram. If both pairs of opposite blank, what do you guys think there? Of the quadrilateral are blank, sides are what? Congruent. Then the quadrilateral is a parallelogram. Theorem 8.8, if both pairs of opposite blanks of a quadrilateral are blank, then the quadrilateral is a parallelogram. Opposite angles, good, are congruent. Real quick, is a rectangle a parallelogram?
Yes.
By definition, does it fit all three of these things so far?
Yes.
Yeah, so is a rectangle a parallelogram?
Yes.
But is every parallelogram a rectangle?
No.
No. Is a square a parallelogram?
Yes.
Yes, because it fits those three definitions, right? But is every parallelogram a square? No. Okay. Theorem 8.9, if blank pair opposite sides, if one pair of opposite sides of a quadrilateral are, look at the picture, are what? Yep. Congruent and parallel. Then the quadrilateral is a parallelogram. And then the last theorem. If the blank of the quadrilaterals bisect each other, then the quadrilateral is a parallelogram. If the diagonals. And we talked about this on 8.2. We said, okay, well, if I have a parallelogram, are the diagonals congruent to one another in length? So would A to D be congruent to B to C? No, but there are only two times that is true. When are those two times? Square and a rectangle. Yep. Go ahead and try A, B, C, and D on number 1 down below. What theorem can be used to prove the given quadrilaterals are parallelogram? So which theorem would this be? Theorem 8.8 is correct. B, which theorem would that be? Theorem. Good. C, theorem which? Awesome. And then the last one would be theorem. Awesome. Good job. Okay, next page. Let's go ahead and plot those points and label each of those points real quick. Back to down 3. I guess I won't read this so that you can do it on your own. Sorry. Okay, so there's my quadrilateral. They want to know if it's a parallelogram, and you have to prove that it's a parallelogram. So if I think about this, so leave your paper on that side, and then I'm going to ask you by these. Could I prove that it's a parallelogram by proving all sides are congruent on a coordinate grid? Or opposite sides are congruent? Yes. Could I prove that it is a parallelogram on a coordinate grid by proving that, oh, sorry, that was parallel. That this is congruent. Could I prove that they are parallel? Opposite sides are parallel. Could I do it that way? Yes. Could I prove anything about
Install.
Yes.
Can you please send Nick Lawrence to the student administration?
Yes.
Do you have a fill out me hall pass, please?
Yep, I will.
Thank you.
Thanks. On a coordinate grid, can I prove angles, measures? No, so I could not prove theorem 8.8. 8.9, could I prove one opposite set of sides is parallel and congruent? Yes. And then could I prove something about the diagonals being congruent at the bisecting on a coordinate grid? I could. I would just draw the diagonals in, and then I'd have to find a whole bunch of lengths. So knowing that which ones I can use and which ones I can't use, which one do you guys want to use? Do you want to prove opposite sides are parallel? Do you want to prove opposite sides are congruent? Do you want to prove one opposite side is parallel and congruent? Which one would be the easiest on this? Parallel and congruent is actually the easiest on this. Because I can look at just BC and AD. I don't want to have to use a distance formula if I don't have to, right? Do I have to use distance formula to find the length of BC on this one? No, because it's directly on the line. So I could just count. How long is B to C? So that is 6. How long is A to D? 6. Okay. What is the slope? You can just leave your stuff here, most likely, I would assume. You don't? Okay. What is the slope of B to C? What is the slope of A to D? Okay. So do they have the same slope? And do they have the same length? So same slope and same length. So by theorem, which one is that? 8.9. It is a parallelogram. Okay. I want for you to try this proof down below completely on your own. I will tell you that this can be proven in about 3 to 4 steps. So remember what to do in this. Your first statement is always your given. Your last statement is always what you want to prove, and then you have to have reasons for each one. So go ahead and try that. What is the first statement that I can say on this guy? The given. So triangle A to B to C is congruent to triangle C to D to A. When you write that, and that's a given. That's the reason. When you write that, you should start marking it. So A to B is congruent to C to D. B to C is congruent to this part, and then the diagonal is congruent to itself. Okay? So right now, I know that all opposite sides are congruent to one another. And that's actually your next step. That A to B is congruent to C to D. And B to C is congruent to A to D. Who remembers the reason why I can state that? So that'll be our next reason. But why can I say that this is congruent to this and this is congruent to this? Yes, good job. CPCTC, remember that back from when we proved triangles are congruent, and that also tells us that all corresponding parts of those triangles are also congruent. So because I know those triangles are congruent, I know that their corresponding parts are congruent. So yes, I know that the next reason is the 8.3, sorry, theorem 8.7. What would my statement be, though? Yeah, just the proof statement. And that one's a short proof. And you're done with that proof. Does that make sense? Going back up to this top one real quick. Let's say that my side lengths were not easy and they're not on straight lines. I'd have to use distance formula. Let's just write down distance formula in case you need it. Someone remind me what distance formula is. Now, she didn't tell me numbers, which is just fine, like x2 or y2. That is fine, because it doesn't matter which x you pull first. But then whichever x you pulled first, you have to pull that same corresponding y first in that point. Okay? Yes? I mean, you might. It's all stuff that you've learned, so you might. If you get any theorems, they won't be huge theorems, and there will probably be a drop-down menu. What? For the test or quiz, is that what you're talking about? Let me look here in a second. I can let you know. Other questions? Okay, so homework is, there's an 8.3 assignment in Schoology and then 8.3 practice C. And then tomorrow is your quiz. Okay?